Lesson 10.5, Distance Formula. Our essential question is, how is the distance formula similar to the Pythagorean theorem? We have one new vocab word today, and it's distance formula. This distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, can be used to find the distance between any 2 points on the coordinate plane. Our first example says find the distance between the given points, 5, 3, and 1, negative 2. The first thing I'm going to do is label my ordered pairs. XY, first ordered pair, and XY, second ordered pair. Remember that your ordered pairs always have an X coordinate followed by a Y coordinate. Now it's just a matter of plugging these in, the distance formula, and solving this huge square root. So I start with x2, which is 1, and in the distance formula, you notice that you're subtracting x2 minus x1. So I will do 1 minus 5 squared plus y2 is negative 2, so negative 2 minus 3 squared. Before I move on, I'm going to check and make sure that I've used each of those numbers once. Next, following the order of operations, I'm going to solve inside the parentheses. So 1 minus 5 is negative 4, and negative 2 minus 3 is negative 5. If I square each one of those, I'll get positive 16 and positive 25. 16 plus 25 is 41. So the exact answer is the square root of 41. An approximate answer, if I round to the nearest tenth, is 6.4. My next example, I'm going to do the same thing, label my ordered pairs, XY, first ordered pair, and XY, second ordered pair, and then plug them in the distance formula. So x2 minus x1, this time gives me negative 6 minus negative 4, plus y2 minus y1, 8 minus 1. My first set of parentheses there, when I'm simplifying, negative 6 minus 4, that's going to turn into a chunky plus. So negative 6 plus 4 is negative 2. So negative 2 squared plus 7 squared. Negative 2 squared is positive 4, and 7 squared is 49. So this one is the square root of 53, and if I approximate that, it's about 7.3, rounded to the nearest tenth. So these two examples show you the basic distance formula. The distance formula, if you are given two ordered pairs, plugging them in the distance formula is really the easiest route to take, as long as you're good at labeling and taking your time. Now, when we look at the distance formula and we've got coordinates that are graphed, I actually think that if you use the Pythagorean theorem, it's a little bit easier. So on a problem like this one, it says find the distance between the points. If you can see where they are on the graph, that's going to be easier than using the distance formula because you could just turn it into a right triangle and count the distance. Now, my grid doesn't look very easy to read, so I'm just going to use the distance formula on this one. If you can see the grid in the background though, what you do is you turn it into a right triangle. Like that, and then you would be able to solve it. You would be able to count A and B for two of the sides of your triangle and solve it that way. So I guess maybe if I just describe it to you, it'll be easier. So if you draw this graph in your notes, let's just say that A and B, let's say that the coordinates for A look like about -3, -1. So I'm going to put my A right here. And then B looks like maybe 4, 2. So I'll put my B over here. Because I do feel like this is really good skill to have. So we're trying to figure out this distance. So that's going to be C. And I'm going to turn this into a right triangle. And you can just count the length of the other two sides. So starting at A, I would go up 1, 2, 3. So this side is 3. And then going across, I go across 1, 2, 3, and then 4, 5, 6, 7. So this side is 7. So you can do 3 squared plus 7 squared equals our hypotenuse squared, because the side that we're looking for here is the hypotenuse. So 3 squared is 9, 7 squared is 49, and that equals C squared. 9 plus 49 is 58, and then the square root of 58 is approximately 7.6. So that's using the Pythagorean theorem instead of the distance formula, because if you're looking at a picture, a graph on a picture, I actually think that that's easier. If you don't want to do that, you could always write A as an ordered pair. So over here, you could always write -3, -1, and then 4, 2 for B, and you could do the distance formula if you would prefer. All right, this next one says find the perimeter of triangle ABC. And it's got coordinates, and so we can graph them and turn them into right triangles if we want to, or we can find the distance of each side. My graph is a little bit hard to see again, so I'm going to draw in some grid lines for you. So 1, 2, 3, 4, 5, and then 2. So A is right here, 5, 2, and then B is 3, -4. So 3, -4. And then C is -2, -1. Okay, so if I connect these to make my triangle, the question is asking us to find the perimeter. The perimeter means that you have to add all of the sides. So to add all of the sides means adding the distances, the length of each side. So add all 3 sides to find the perimeter. So it's either doing the distance formula 3 times, which you could do. You could do the distance from A to B, B to C, and then C to A, 3 distance formulas, or you can use the Pythagorean theorem. So I'm going to stick with the Pythagorean theorem because I think that this is easier for me when I look at a graph. So I'm going to count these sides and turn them into right triangles. So starting at C and working to A, I'm going to go up 1, 2, 3. So this side right here is 3. And then I'm going to go over 1, 2, 3, 4, 5, 6. So this side is 6. So 3 squared plus 6 squared equals, and this is for side AC, AC squared. So 3 squared is 9, 6 squared is 36. If I add those together, I get 45, and that's A squared. So then I would have to do the square root. So the square root of 45 is about 6.7. So this one is about 6.7. Now I'm going to move over to a different side. I'm going to do AB next. So AB, if I turn it into a right triangle, this side is just 2. And then this side is going to be 6 again. So 2 squared plus 6 squared equals AB squared. 2 squared is 4, 6 squared is 36, so 40 equals AB squared, and then I would do the square root. So the square root of 40 is about 6.3, so this is for side AB, 6.3, and now I only have one left. For this last one, I'll do the distance formula just in case you prefer the distance formula. So for BC, I'm going to do this big square root. I'm going to label these x1, y1, x2, y2. So square root 3 minus negative 2 squared plus negative 4 minus negative 1 squared. And stop and check, make sure I've used each number once. X2 minus x1, y2 minus y1, okay. So both of these turn into a chunky plus. So 3 plus 2, and then negative 4 plus 1. 3 plus 2 is 5, and 5 squared is 25. Negative 4 plus 1 is negative 3. Negative 3 squared is 9, so this one is the square root of 34. The square root of 34 is about 5.8, and the perimeter, we have to add all of these sides. So 5.8 added to my 6.3 and 6.7. Give me 18.8 for my perimeter. So you can use graph paper if you're solving a problem like this. You can use the distance formula 3 times, or the Pythagorean theorem, or a combination of both. Our last problem is to find the area of a triangle. Remember, area is base times height divided by 2. Base times height divided by 2. For this triangle, we know 2 of the sides. We don't know the third side. Remember that when you use the Pythagorean theorem, you have to make sure that you've got the hypotenuse in the correct spot. The longest side on this triangle is 10, so my hypotenuse is 10. That one has to be substituted for C. Then the legs are X and 8, and the order that I use those doesn't matter. So my equation, x squared plus 8 squared, which is 64, equals 10 squared, which is 100, and I can solve it by subtracting 64. So x squared equals 36, and then I need to take the square root to get x by itself, so x equals 6. So now I know that x equals 6, so I can plug that in my area formula, base, the base of my triangle is 8, the height is 6, and then divided by 2. So 48 divided by 2 is 24. So my area is 24 units squared. So with the right triangle, to find the length of the missing side, you need the Pythagorean theorem. And then to find the area of the triangle, once you know that missing side, you do the base times height and divide it by 2. That's the end of our lesson for today, so you should be able to write a summary now answering your essential questions.